Greetings, everyone in Theater 15, the best audience in BSidesSF. Give it up for Alex. He'll be presenting. He'll be our presenter, and he'll be our master of ceremonies for the next 30 minutes.
Awesome. Thank you very much. Hello, everybody. I am all kinds of excited to be here. This is my first talk that I've ever given in person ever since like the before times. Thank you very much. Today, I'm going to tell you guys a story about our journey at Lyft through the ups and downs about container vulnerability management. It was a disaster. Well, we're trying to make it a little bit less of a disaster, and I'll tell you all about it. So back in 2020, we stood up a vulnerability management program. And at that time, this was frankly, a little bit embarrassing for us because we felt that a company of our technical maturity, well, this was table stakes. Like we needed to have this done already. And prior to having a formal program, what we had done was vuln management was done in an ad hoc basis, and this was a mess. So what we did, we also had another big reason, a big motivator for standing up a centralized program. We wanted to win a contract to provide rideshare services for the federal government. And the federal government needs to ensure that we protect their data. And so we needed assurances that we had operated a program that would find and fix security vulnerabilities on all of our platforms that were involved in this flow. So for those of us on the security team, I just realized I totally didn't introduce myself. Yeah, so I'm a SWE on the security team, by the way. And so this was exciting. This when the hell does this ever happen where you work in security and you can say that, I am no longer a cost center. I'm not that thing that is costing the company money for some dubious benefit. This is literally tied to a business item. So I personally was extremely thrilled to be to be able to say that you can be part of some business generating story. So we set on this, and one thing that this talk is going to be focused on the container part because there is just so much to cover here. There's a lot of technical depth. And then so the hope that I have by sharing this with you, avoid our mistakes. I'm going to go into the good, the bad, the ugly. And containers are hard, so let's share notes. I'll go over the things that worked for us, how we used a graph approach to get to the bottom of actionability. One thing that I'm loving seeing at B-Sides this year is that there's this theme with taking a pragmatic approach to vulnerability management, looking and deciding and prioritizing what specific things your program can do. And as a security team, just not doing everything, but being a little bit more smart about it. And then so I think that standing up a vuln management program from scratch, especially because we had a specific customer in mind, this let us be we needed to be very deliberate about what things we covered first. And I'll take you through our thought process. So thinking about things, well, the customer that we had in mind for this specific program, they're interested in rideshare services. So when a Lyft customer goes and calls up the rideshare app on their phone and requests a ride, it talks to a number of back-end services that are hosted in the cloud. And we run about 1,000 of these services at Lyft. It's quite a few of them. All of those services are deployed on Kubernetes. I imagine that all these talks I've been attending here, everyone is very familiar with cloud-native technologies, so this is pretty exciting. So they run in Kubernetes, and then so some of those, there are other assets that are involved in this flow. Some of them are exposed to the internet or not. And so this is the way that we're kind of building up those components that were involved for our program and thinking about, okay, well, we got containers, we got Kate's nodes, we got other assets that are hooked up to the internet. Again, I'm going to focus solely on containers because there is a lot of technical depth in this section. What are we going to do with containers, though? So generally speaking, a vuln management program has steps like this where you inventory your assets, you perform a scan on them. And then after you do your scans, you have a set of results. You want to do some triaging. You need to decide, given this issue, is it critical enough? Does this need a all hands on deck type situation? Or is this something that is significantly less critical where it can wait a little bit longer? Or is it not valid at all? And so can I just avoid randomizing my security team? And then finally, you need to actually get something done. So once you get all your issues, make sure that you're assigning it to the correct team and then actioning on them. And that's the key part. Making sure as the security team, like if we're just spamming out tickets to teams and no one knows what to do with it, we're not doing our job. We set out to do this program and we did it pretty bursty. The goal was to get from 0 to good enough as fast as possible. So we set aside about 6 weeks to just build out a minimum viable product. And we found out that there were a couple of things that we didn't quite anticipate, that we did our best here. One of these difficulties was scale. And I'll talk through a little bit of some of the uniqueness of Lyft Infra. I think that many of you may be empathetic, hopefully. So at Lyft, when a developer pushes a commit to GitHub, a container image is built, and then it gets pushed to an ECR repo, Elastic Container Registry. And this happens regardless of whether or not that container actually is deployed to production. That's an important detail. So if we were to take the naive approach, we're doing the scan process, right? We're trying to find out where are all the vulns across our entire company. And if we did this one by one by image, and let's ballpark maybe about 15 seconds to 30 seconds for an image scan, then it will take months to scan all of this. And even more so, even if we could massively parallelize all of this, that's just a lot of money wasted on compute, and who wants to do that? And I guess like by the time that you're done with all of this, then the developers are going to go and push out more code again, and then your results are, well, worthless. So we had to take a little bit more of a pragmatic approach and think, okay, which of these images actually presents a risk to us? Which of these images is exposed to production, running in production? Which of these commit hashes, revisions, is going to be set out in the wild and then serving rider traffic, driver traffic, that kind of thinking. And the next part was actionability. So this is something really interesting with container images. So we initially started this project by using things that were available to us, easily available. So every container image, we scan them with AWS's built-in ECR scanner. And if you look at the API documentation right there, it's got attributes, description, name, severity. It doesn't tell you what to do with it. Like, going through this, I don't know what to do. At least, I know that if it's critical or whatever, sure, but it doesn't tell me what version to actually fix a given package to. And then so if I what am I supposed to do? I take all these findings, I give it all my service teams. They'll tell me to go pound sand. They'll tell me to go away. Yes, ridiculous. And another thing with actionability is with images, we have our infra team maintains the parent base images. I think that a number of companies do it this way, where your application teams, they cannot and probably should not maintain the full stack of that image from the OS to all the stuff that they build on top of it. So typically an infra team or somebody who is really well versed in this, they're going to be building up the parent base image, and then the application team will add more material, or they add their own code, and that gets built as their image. So it forms this sort of family tree. So there are two classes of vulns in image lineage. So there are vulns that the service introduces themselves. So if service imports or introduces some package that they need. There are vulns introduced by the parent image. And then so as you see, like if there's a vuln introduced by the parent image, it's going to cascade down to all of the children. How do you fix this stuff? So the first case is really straightforward. If you want to fix a vuln introduced by a service, you just tell the service, this is the package you need to fix. All right, done. How do you fix the other case? How do you fix the case where the vulnerability is introduced from a base image and has been cascaded down through everybody else? This is a little bit more challenging, because if I was to scan one of these service images down at the bottom, cut tickets, and then tell that team, you need to go and solve this issue with OpenSSL or whatever, they will say, cool story, bro. I have no idea what to do. There is absolutely nothing that they can do to fix that. What needs to happen is that the infra team will need to pull in their own changes, update the image, and then cascade those fixes down to the rest of the fleet. So that's what needs to happen. So the infra team will update that image and then cascade it down. And we're lucky at Lyft, we have a really awesome infra team where we have a process that automatically cuts pull requests to every single child service down at the bottom layer there. And so services will effectively consume the fix from those auto-generated PRs. So image lineage is a graph problem. And how do we keep track of all of this? We luckily have one. I maintain an open source tool called Cartography. You can check it out. Lyft has been maintaining this for a while. It's really awesome. For full details on how this cascade process works, check out this blog that I wrote. And because this is really interesting, because this can be several layers deep, a dependency of a dependency of a dependency. Oh yeah, you can check that out right over there. So essentially the power of having something represented in a graph like this is you can correlate this context with anything else, like such as who owns a service, or correlate it to the on-call in charge of fixing this attribute, the ownership, do things like connect it to internet connectivity. And then we saw the value there, and then so we took all of our various scan data, and then we chose that we would have this sort of naive architecture where essentially everything is going to get sent to Cartography, and then we are going to output those as Jira tickets and then reports, call it a day. And we built some data models. I'm not going to go over what these data models are, just to show you that you can model it as sort of a graph. And yay, we won a contract. Yay, $810 million split between Uber and Lyft. That is awesome. Well, we're not done yet though. So like we had a data model, and we had the contract, but this was really bad. We did not have any automation to do this. So remember that we had this plan, right, where we were going to scan for vulns, we were going to triage them, we were going to remediate them, and we were going to live in this beautiful world where robots were doing this for us, because as a security team, we're all understaffed, and then we're very tiny compared to the rest of the company. And then so in actuality, it looked like this. At the end of the first 6 weeks, we had focused only on the discover piece. We only had a scanner. We had some data model that I frankly was very proud of. Like, oh, look how smart this is. Well, but it didn't actually do anything. So the parts that involved triage and remediation, this was all still very much manual. And there were resourcing problems here. So at the end of the 6 weeks, most of the team that was focused on this, we all went back to our main projects. We all went back, and then this was left in the hands of one TPM and one very capable engineer, but they both ended up extremely burnt out. This was dark times. This was really bad. And then especially couple that together, this was 2020, and then the pandemic, no one was having a good time at this time. And something had to be done. We had to, the next step, we tried to think, okay, what are some things that we can do to build, buy, adopt our way out of this problem? And are there things that we can augment with our existing structure that we've built out for ourselves? And one of these was a tool called Chantavy. And so Chantavy is really neat. And what I like about Chantavy is that it gives us fixed versions. You scan the image, and then it tells you exactly, maintains a data feed, tells you exactly what package to update your vulnerable package to. Next one, it tells you, you can say things like, if this vulnerability is not fixable, don't even tell me about it. If there is nothing I can do about this vulnerability, then why am I going to spam all of my service teams? Unless, of course, it's a log4j type situation, in which case it requires a all hands on deck situation. But majority of the time, that's not going to be the case. And the cool thing with Chantavy was that it also lets you define things like open policy agent definitions. So you can say things like, if this vulnerability requires in-person access or physical access to a server, I don't care about it. And you can describe it like that, and it will filter it out all for you. We loved that. And then I guess the one final point I'll have on the build by adopt point is that we found that our infra was just so custom to the point where a lot of the things that we evaluated, they kind of took a very opinionated way about how the infra would be set up. And so it didn't really generalize well. And then the work to sort of orchestrate all of this, or the work to adopt their product, would have been just the same or more than just doing it ourselves. And so that's what ended up needing to happen. We orchestrated the automation ourselves. It ended up looking something like this, where, again, you got the scan process. You're identifying what is in production. You're building this image lineage tree. You're splitting up those vulns into things that are inherited from the base image to things that are introduced by the service itself. And then you are tying that up to what the team can specifically do to fix it themselves. And then so that's that remediate piece right there, where we say that your project is affected by this many security issues. And here is the specific PR that you need to do to merge everything in. And once you merge that in, all of these security vulnerabilities, they will go away. And I guess I skipped over real quickly the triage phase. That's, you have to do there's sometimes some hand tuning about like deciding what are the types of vulns that you care about or not care about. And we had this state management system that was really sophisticated. I'm not going to go into this. This is to say that this was a very ambitious project, and it failed spectacularly. We did our best here. And I'm going to tell you exactly how this failed spectacularly. I wanted to share like the original code segment for this, but then I thought, okay, well, it's not. I'll just show you the screenshot right here, where if you are on call, the security team's vuln scanner may have assigned a Jira epic to you with no task items attached to it. When the scanner finishes its job, all tasks and subtasks will be attached to the epic. We expect the scanner to be done by the end of the day. Whew. Okay, so like what happened here was, we sent all these teams, all these tickets. We were unveiling our brand new launch of our program, and then we told them they had all these things to do, but then there was no detail about what they had to do. The weird details like this, weird state management details about like at the end of all of this, we should have waited for all of the scans to finish before assigning it to the service owner, so that they would not get spammed with an email that they could do nothing about. Okay. This one was worse. Security vuln tickets were closed erroneously between 6 and 7:41 a.m. This was really bad. So service owners sent erroneous information that vulns were closed that when they should not have been. This is a bad situation to be in when your state machine logic goes, and then what happens is it believes, due to a data quality error, that all vulnerabilities that you have sent out to all the teams have been resolved, and therefore all the tickets that you have sent out to them should be closed. And so like you have 0 open tickets, and then so at first it's like, oh, we can pack it up. It's a great day for security. We win. Inbox 0. No, this was definitely not the case. And so we sent out an apology, and in certain cases, we actually had to send an apology about our apology because, oh, wait, actually, we're going to backtrack on that. This is a bad place to be. You do not want to be here. And well, eventually it worked. What did we do to make it all work? And before I get into that, that's a key detail here. This was really ambitious. The part that I really want to emphasize was we decided that sending out tickets to teams, this was not an acceptable experience if that ticket, especially the given volume of data, was not going to be automatically closed. So we had state machine logic that would detect that the vulnerability was gone. So if that vulnerability was gone from the environment, we would close it, and then we would do our own bookkeeping on the back end and keep everything nice and tidy. So in my opinion, I think that if you don't have that, then, if we didn't have that, then we weren't really doing our job. So eventually, ambitious plan didn't work out at first. Eventually it did. Why did it work out? Well, due to the work of many other members on my team, we built engineering safeguards. We did things like kill switches. So this one is like, all right, well, if we get ourselves into a really bad situation and we need everything just done, then we can just flip that switch and then just skip over closing the rest of the state machine. How do we get our robot to stop running away from ourselves? We have a circuit breaker where if the number of tasks that we're going to close is greater than some threshold, some sanity check, then we will stop it right there, and then we'll page our own on-call. We have a set of dashboards and alarms. We built a set of systems that count the number of assets that we have in our cartography-powered graph, and then we kind of measure exactly, okay, well, if you can chart these things, you can set alarms and thresholds for if this number goes below or above a given threshold, you can page the on-call. And this last thing that we did right here was to staff the program properly. And I think that this was probably the biggest, I don't want to say mistake, but I think the biggest area of improvement that we could have made from the very beginning, where, like I said, we started off in a surge effort, and then afterwards the ownership story was unclear. Where we turned it over, there was only maybe 2 people working on it, and then other people came back in as volunteers to help get things in a good state again. The final thing was we stood up a dedicated program, a dedicated team for vulnerability management itself that handled things like building out the platform, the care and feeding of these software systems, answering questions when people got confused as part of the on-call, and maintaining all of this. So this was absolutely critical for us. And so I want to talk about the things that we learned. There were things that, going back to, I think that if we were to think about it from the original times, we did things really well in certain areas, and then there were definite some places that we missed, such as those engineering scaffolds and then staffing things properly. So actionability is everything. I think that I'm pretty happy that we took this approach where if there is nothing that a team can actually do for vulnerability, then why bother them? Unless it's an all-hands-on-deck situation where it needs special care. We have to balance all of these things. There are competing priorities. Prefer fixing over telling. We needed to be part of the solution. So in order to get our teams to work together with us, we took a partnership approach and then we leveraged the existing work that our infra teams had provided for us, this system that gave automatically generated pull requests to update the rest of the fleet and then pull down those fixes for all of the downstream services. Automate for user experience and for team health. So this is a very important point. So having, again, for us, I think that it's a very unacceptable user experience to take all the findings, scan findings, shoot them out to all of the on-calls and say, good luck. And, we don't have, especially with the given volume that all of these, that we had of tickets, this is not acceptable. So we built some state management that handled all of that on the back end and automatically closed those tickets. Sure, we had some problems with rolling that our own and owning it ourselves. But I guess the next part is, when it comes to the aspects of team. So having automation for your team, if there's any manual step in your vuln management program, I would question how sustainable that is, because I know that when we went through it, this was really rough and we definitely burned out a lot of people. And yes, with the state management, use engineering safeguards, think about these things ahead of time, do a phased rollout. I think that we could have did things like, let's first onboard only the security team to this process. Let's do some dog fooding of ourselves, and let's do like a 20% rollout, 60% rollout, and then see how the teams respond to it, and then iterate and go from there. In our case, we had a lot of deadlines staring us in the face, and then we had a very motivated customer telling us, oh, you need these reports right now. And so we had to sort of change, we had to improve the engine while driving it at the same time, and that was very difficult. But yeah, if a lot of this was thought ahead of in advance, I think we could have avoided some of those problems. And then finally, this last part is take care of each other. And then this is especially true for the time when we put this all together. This was during the pandemic, during probably some of the worst times in a lot of our lives, where we're all confined at home. And then a lot of us had been meeting each other only over a video call, not really building that team rapport, seeing each other in person. And there's many aspects. So what does this actually mean, right? What do you do to take care of each other as a team? And what I would say to that is it comes in many different places. And the first part is pushing back against unreasonable deadlines. So if you're getting a requirement, and then if there's a very high time, if there's a very urgent request, I would be very critical of what that request would be. Is this really all that urgent? Is this really all that important? And then kind of like make your own matrix about what that looks like, because above all else, if you have a team that's burnt out and not willing to work, that's going to be very unhappy for everybody. And on the other hand, if you have a sustainable set of team practices, then this will pay dividends in the long run. And, thank you very much for having me over here. You can check out Cartography. You can reach me at the various socials. We built out this approach. I'm very interested to see how others have solved this problem, taking things where you are scanning these container images, you're finding out where the finding was, if it was actionable or not, focusing on this, making sure that your team does not have toil, owning the state management, doing this in a life cycle process, the care and feeding of your program. Definitely extremely excited and happy to be here. Thank you very much.
Fantastic. Thank you, Alex. Folks, we have time for one quick question, and then most QA, we would encourage you guys to do that in the hallway to make room for the next speaker. I see a hand up. I'm bringing the mic, and I'm not going to fall this time.
Hey, thanks for the talk. Very interesting. So, quick question. On your MVP, you said you did it in 6 months. How many people did you have?
6 weeks.
6 weeks, sorry. 6 weeks. How many people did you have? And eventually, how many team members for the actual, I think you made improvements over time and to get it operationalized?
Yeah, so with the original MVP, I think that there were 10 to 15 originally across the entire company from infra, and then this was not on just containers, though. This was, again, on the other work streams that I mentioned, including the K8s nodes, internet exposed assets, and then all of those other things. And then eventually when we built out the full team, this ended up being closer to 3 to 5 people. And so 3 to 5 still sounds like it is a very, very small team. But what I will say is that it is amazing what things can do and how much more fast you can move when the lines of responsibility are crystal clear. When everybody knows I'm working on this vuln management platform and this is what I am going to be evaluated on, or this is like the thing that I own. That's a real powerful thing. Like when people are able to take ownership over a project and then make their own contributions. It multiplies.